Welcome back. In today's video, we want to talk about force. So the unit of force is in Newton. So we're going to put that in parentheses. And where 1 Newton is 1 kilogram meter per second squared. So 1 kilogram, right, per meter second squared. Okay. So the Newton is defined as the force which, when applied to a mass of 1 kilogram, gives it an acceleration of 1 meter per second squared. So we can then see here we have the mass. So it's defined as the force which, when applied to a mass of 1 kilogram, so here we have the mass, gives it an acceleration of 1 meter per second squared. So we have the meter and we have the per second squared. So we can see that in the units for the force. Okay, so we then go ahead and write the equation for force, and that's mass times acceleration, where m is the mass in kilograms and acceleration is in meters per second squared. At times we would like to know g, and g is the acceleration due to gravity, and that's 9.81 meters per second squared. Okay, so say for instance we have a mass of 5,000 grams. So m is equal to 5,000 grams. And that 5,000 grams is accelerated at 2 meters per second squared by a force. So the acceleration is equal to 2 meters per second squared. Determine the force needed. Determine the force needed to move that mass at that acceleration. And we have the equation up top, which we see is right there. And we know that the force is equal to, and in this case, we would have to convert the 5,000 grams to kilogram, and that would be 5 gram. So then we would get 5 kg times 2 meters per second squared, and that will equal to 10 Newton. And Newton, again, is straw. And my pencil seems not, okay, there we go. And that is the unit for the Newton. All right, say we have another example, and we would like to find the force acting vertically downward on a mass of 200 grams attached to a wire. So let's erase this. And we can just go ahead and just take this away. So say we have a mass and a wire. So just draw the wire without anything else and just a box. And this is M. And G is acting downwards. And so we have no normal force because it's not connected to any surface. But we could have in the wire two different force acting, the force acting on the mass and the force acting on the wire. But we're not going to consider that. So find the force acting vertically downwards on the mass of 200 grams. And that's attached to a wire. So the solution would be the mass is, you convert that gram to kilogram, that would be 0.2 kilogram. And the acceleration due to gravity, because in this case, there's no sidewards acceleration, so we have no horizontal acceleration. So if the mass is in free fall and the acceleration is acting downwards, it's gravity. So then we know that gravity we have here. So we then go ahead and we multiply this again. And to find the force acting downwards, we'll just multiply the mass times the acceleration, which is this time going to be m times g. And that comes out to 0.2 kilograms times 9.81 meters per second. And that would be meters per second square, actually. That would be not 1.962 newtons. And that would be the force acting on the object. And that force is vertically downward. So I think that's it for force. And we'll see you in the next one. Bye.